Good morning, everyone. We'll start a tutorial on sentiment analysis. Okay, our tutorial will divide into two parts. First part, I will give you a general introduction of sentiment analysis and give you a brief idea of what it is and what natural language processing is. And then my friend Kishaloy will give the second part of the tutorial. He will detailedly tell you the techniques of how to do sentiment analysis, how to use some functions, some programming code, yeah, some technical things, yeah. So, yeah, okay. The first problem is, what is sentiment analysis? So sentiment analysis is identify the orientation of opinion in a piece of text. So for our in our text, so there for our text can be divided into two categories. First is factual. It just neutrally or or objectively states one fact, right? But in some sentences or text, we will express our emotion. It can be positive and negative. So first example, this is a sentimental statement, which has positive sentiment, and the second one is factual. It also can be called neutral. And the third one is horrible. You can say it is negative. It is very useful actually. So, but before to use the application, I will introduce more background. So this is since this is useful. So psychologists has already studied a lot, and they divided our emotion into very detailed categories in a very detailed granularity. But we will not go to that in details. Generally, we will just classify positive and negative. Yeah. So it is useful. For example, this research studied the sentiment in tweets, the correlation between sentiment in tweets and the Gallup Poll of consumer confidence. You can see the blue line. The blue line is statistics of sentiments in tweets, and the black line is Gallup Poll of consumer confidence. You can see there is a sharp increase and in Twitter sentiments, and there is a increase in for the Poll of Gallup. So you can see the Twitter sentiment can somehow predict the consumer confidence. Okay, so another interesting research is use Twitter sentiment to predict the stock, which means we can earn money on it. So this research studied several different kind of sentiments. Can study calm, alert, kind, happy, and this is okay. You can see this is Dow Jones. This is the Dow Jones index. The blue line is the Dow Jones index, and the right line is calm sentiment expressed or discovered in the Twitter. So you can see they have a very close correlation. Yeah. So these are two applications which that sentiment analysis can directly help our research, our markets. Let's go to more technical parts. Sentiment analysis, it has many other names. In research community, it can be called opinion extraction, opinion mining, sentiment mining, and subjectivity analysis. Okay. Our human beings can easily understand the sentiment of text. How a computer can understand it? So let's go back to our simple intuition of human beings. And the computer actually mimic our human intuition to do it. So you can see there are two sentences. The first one is negative, and the second one is positive. So what hints us the body, the word hate and like hints us the sentiment, right? So the basic algorithm or the most naive model is to count the polarity words. Given a sentence, we just count how many positive words are there, how many negative words are there. Then we can get the most, get our first baseline to do sentiment analysis. The problem comes, how do you know? How do computer know that once one word is of positive or of negative sentiment? Okay, luckily, linguists and psychologists have already studied it and have they're handcrafted a lot of dictionaries we call lexicon to classify the sentiment words. So I will introduce you some resources. Perhaps you can use it in the future. The first resource is General Inquiry Lexicon. It is from Harvard University. This is the homepage. This is the homepage of this project, and basically it's category each word in different categories. They predefine about 100 categories. Two of them are positive and negative. So they classify each word into different categories. For the positive category, there are about 2,000 words, and for negative, there are more than 2,000 words. So this is an example of general inquiry lexicon. So perhaps you can see it clearly, but you can download our slides later. You can see each row is a word, and each column, the first column is the words, and the subsequent columns are the label. So you can see some words are positive. You can see a clear version. In the download the slides. Okay, this is the first lexicon, and then there is the General Inquiry Lexicon from Harvard University is very old, actually. So there is a more recent one. It is published in 2007. It gives more updated categories, but it only counts 2,300 words. And it also gives some negative annotates some negative emotion or positive emotion of each word. So this is a link of this lexicon. But this lexicon will charge you 30 to 90 US dollars. The Harvard one, the General Inquiry Lexicon, is free for scientific research usage. Okay. Previous two lexicon are handcrafted, which means human annotated. So some researchers also try to automatically generate some sentimental lexicons. For example, this is the MTQA subjective Q lexicon. Okay, so since it is automatically generated one, it has more coverage. It covers about 7,000 words. 7,000 words. Then, positive words is about 3,000, and the negative words is about 5,000. Okay, and different from previous two lexicons, it also annotates the intensity of the sentiment, which means for one word, it will not only tell you whether it is a positive one or negative one. It will tell you whether it is a strong positive one or strong negative one or weak negative one. Okay. Another one created by Professor Binliu. This is also a famous lexicon. Okay, the last one is SentiWordNet. SentiWordNet is a subsequent project of WordNet. So the idea of WordNet is that each word has different meaning. So different word could have the same meaning. So how can we link the different word of the same meaning or the one word of different meaning? So yes, WordNet deal with this situation. The human annotated the different meaning of each word. It is called synsets. For example, estimable as an adjective, it can have a different meaning. For example, this one, yeah, it can mean may be computed or estimated. It can also mean deserving or respective or high regard. So yeah, so based on WordNet, some researchers annotate the sentiments on the synsets. Yeah, recall synset is the meaning of each word. So, for example, the estimable for this synset, it is not sentimental words. It's just an objective statement. But for this one, yeah, it is a positive word. Oh, yes, slides cannot show it. Sorry. Okay, this is an interesting discovery. Since we have so many lexicons, will this lexicon contain the same information? Yeah, some researchers compared it and find there is a lot of disagreements between each sentiment lexicon, which means the sentiment itself has an ambiguity, right? So this indicates, yeah, sentiment analysis is a very subjective task. So there is no clear cut. That's why sentiment analysis is difficult. But the good news is, yeah, it is not so huge. The disagreement is not so huge. So the agreement part is a basis for computational sentiment analysis. Okay, since we have these lexicons, is it enough for our sentiment analysis? The basic algorithm is just count the number of positive words and the negative words, but there is still a lot of program to solve, right? For example, first problem is inaccurate sentiment lexicon. Since there is a agreement, meaning the lexicon is not accurate, not completely accurate, right? The second problem is out of vocabulary sentiment words. Yeah, what if one word appear, but one word doesn't appear in any lexicons? How about multi-word expression? Yeah, previously these lexicons just deal with single word, but we know when multiple words come together, the meaning can be different, right? So how to deal with this? And also, the negation is a very significant phenomenon in the sentiment analysis. You can say, yeah, both two sentences appear contents word like, but yeah, the first one is negated. So yeah, they should have different sentiment. Okay, so this problem tells us simple rule-based counting sentiment word algorithm is not enough. So recently, we usually use statistics-based machine learning algorithm. The assumption or the hypothesis of statistically machine learning-based algorithm approaches are, yeah, the different sentiments should have its own pattern. So we usually tend to use some patterns to express the positive sentiments and tend to use some other patterns to express negative patterns. What's the pattern? Sorry? Yeah.
So how can you deal with sarcasm in the text sarcasm?
Yeah, somehow, yeah, there is some research does it, but yeah, the performance is yet to be very good. Yeah.
What is the main idea?
The main idea is, okay, there is also some phenomena. For example, yeah, if we, okay, in a context, there is all negative words or all negative expression, but there is a sentence standing out with a positive, strangely appear a positive sense, then yeah, this might be strange, right? This is first the simple intuition, but there are many others. Yeah, we can discuss after tutorial. Yeah. Okay, so go back to our machine learning approaches. Since they have their own patterns, okay, the idea is we do not summarize, we do not create rules. We just put all the things to the computer and make the computer to do the statistics. For example, we give the computer data sets which contains 10,000 or 100,000 positive sentences and 10,000 negative sentences, and make computer to do the statistics. If some phenomena appears frequently in the positive data set, which means this means this phenomena or these statistics will be a strong evidence for the positive sentiment, right? So there are many machine learning algorithms proposed. For example, logistic regression, SVM, which means support vector machine and decision tree, and recently the very hot classifier is neural networks. Okay, they are very how to say, very popular algorithm, and it has already been implemented. So you can easily download from the internet. You can just Google it, and there are many free resources to help you to do the machine learning. Okay, but it's less effective and efficient to put all the words of the sentence to do statistics. Instead, we just encode some information, extract some information to feed it into machine learning algorithm to do statistics. For example, this sentence, we just put, okay, this since the heat is a clue to understand the sentence, we just put we just encode. For this instance, we just encode there is a negative word in a sentence. Okay, for the second sentence, yeah, we just since the didn't and like are the clues, so we just include for this sentence we have a negative word and also a positive word. So we hope machine can learn. Yeah, once a positive word combines with negative words, it will indicate. Oh no, so sorry. Hopefully, we feed the sense into machine. We want machine to learn the negative words combines, negate words combines positive words, indicates negative information. Yeah, since they are very commonly appear in our corpus, our data set, so machine can learn it. Okay, so go one step further. These are the features proposed in past 10 years. Yeah, they have been proven to be useful. Okay, first feature is the syntactic feature, which means how the words combine together. For example, this one, Han et al. In 2002, they studied a sentence containing an adjective and this mark, then it will indicate the opinion. Yeah, for example, this book is great. Yeah, this is a noun, this adjective, and this comma, this mark. Okay, if they all appear together, then they will indicate a sentence. Okay, the second one, this research indicate that if a noun is followed by the adjective, it will represent some sentiments can be positive and negative, depends on what the adjective is. Okay, so this research also indicates the modifier is useful. If adjective appears or co-occurs with modifier, for example, very, mostly, it is likely to be a positive one. If it is co-occurs with not, it is could be is likely to be negative, positive one. Okay, there are even more complex statistics. Okay, for this research, they use a co-occurrence of one phrase between one phrase and an excellent and poor. If a word is or a phrase is likely to co-occur with excellent, this phrase is likely, not definitely, but is likely to be a positive one. If a word co-occur with is likely to co-occur with poor, then it is possible that this word or phrase is a negative one, right? So they just give a huge data set and they just do statistics. So to see how often this phrase co-occur with poor or excellent, then they will probably assign some possibility of sentiment of some of a specific phrase. Okay, so this is a general overview of sentiment analysis. Since this is an introduction tutorial, I will also introduce you some relevant topics to conclude my part. Relevant topics are there are three most frequent relevant topics. First is creating sentiment lexicon. So since we say sentiment lexicon is very important, but we usually handcraft someone. What if they are not enough? So there are a lot of words, right? Our human beings, it's difficult to cover all the words. So the interesting topic is how to create a sentiment lexicon. A bundle of research have been conducted. Okay, the second one is aspect level sentiment analysis. So in one sentence, there may be multiple sentiments towards different aspects. So if we just treat one sentence as a whole, it's the granularity perhaps be not enough, right? So very hot research project or research direction is aspect level sentiment analysis. And also the detection of friendliness is very useful in chat robots. For example, in automatic chatting robots, right? You say you chat with them with a very angry, very aggressive mood. Perhaps it will give you some corresponding output or some proper response. If you chat with him with a very friendly attitude, it will give another kind of proper response. This strategy is also applied in our as our human beings in our human communication, right? So the first step is how to detect the friendliness of the sentence. Okay, go to details. How to create a sentiment lexicon. Okay, a simple intuition is the conjoin, yeah, the conjunction. If a sentence, if a word is conjoined by and, yeah. Okay, adjective conjoined by and should have the same, is likely to have the same polarity, right? For example, yeah, take this as an example, fair. Yeah, if we know fair is of certain sentiments, it's likely this word is also the same sentiment, right? So since we have already handled human crafted data set, we just search everything in the Google, and then Google will return us some text, right? For example, if we search nice and, okay, Google will return us this. Okay, you can say nice and helpful. So helpful is most likely to be positive word. So yeah, also nice and classy. Yeah, so this is also, yeah, very useful to handle a crafted lexicon. Okay, the second topic is aspect level sentiment analysis. Yeah, for example, this sentence. Within one sentence, two sentiment polarity are correlated to two aspects. Food is great, but service is awful. So how can we, yeah, extract the aspect and its corresponding sentiment? It is very useful in e-commerce. For example, in hotel review analysis, yeah, it's often it's very often that one customer comments someone is good, someone is bad. So if we collect all this data and do statistics, okay, we can say which aspect should be improved in this hotel or in this service, right? So the basic intuition is the aspect that occurs near the corresponding sentiment word. For example, food is near great, right? Service is near awful. The problem is how to define near. Yeah, it requires some linguistics. So the near don't means the, how to say, don't mean the how many words it's how many words are between them. Yeah, the near one possible measurement of the near is the grammatical distance. So because the food and the great are in one, these two words are in one clause, and the great and the service are with the are in separate clause. So food and great should be near. Yeah, there are also many other definitions of the distance. Yeah, but I just give you some simple intuition. Okay, the last slide. Yeah, the last topic is the detection of friendliness. Okay, friendliness. The intuition is friendly speaker uses collaborative conversational style. Yeah, they really laugh, they more sympathy, they show more agreements, and they are less agents. Yeah, we just use these clues to, again, to show to do the statistics, yeah, to get the classification done. Okay, this is a general introduction of sentiment analysis. Then my friend will go to more technical part for sentiment analysis.
Good morning, everyone. So thanks, Wenqiang, for introducing the problem in general and talking about some of the problems of the natural language processing that we face. So I'm going to talk about a little bit specific about sentiment analysis, like how it can be done in social media. I think we do not need to discuss about the importance of this task, because these days, like starting from e-governance to e-commerce, everywhere these kind of things are getting very popular. So I think there's a wide spectrum of audience. There's a wide spectrum of audience over here. So I'll try to get things from both the spectrum, like a little bit of advanced stuff, and also like things that can be like understood by who are not familiar with natural language processing also. So let's get started. So I think Wenqiang has already mentioned about the task. So basically the task is to, like, given a piece of text, how do you classify whether the text is positive, negative, or neutral? So neutral texts are almost always factual, but we are interested about the positive and negative part. So the text can be like a tweet, a Facebook post, or it can be a customer review on a hotel, or a product review in Amazon, anything. So there is another class of task which is called emotion analysis, where you try to find out like what is the emotion going behind this particular piece of text. Like it can, whether it's talking about joy, sadness, or stuff like that. But we are mostly not going to talk about that because this is not in the scope. But we'll briefly touch upon about some of the emerging research topics which talks about this thing. Moving ahead, there are like several domains where this could be applicable. As for example, you can see there are a couple of the upper part of this list is basically comprising of the formal text from formal domains, where the English is very clear and also the words are mostly coming from the English dictionary. Whereas if you consider in this talk, we're going to focus on the lower part of the spectrum, where this is generated by common people. So there is less structure in it, and the text would be informal. So they are collectively called as social media text. So the big question is how social media text is different than the formal domain. First of all, it is very informal because of a lot of slangs that are being used in generating those texts. Also, these are very short in nature, so long dependency to trees that exist for like formal domains may not work over here. And also there are like, if you are, I think everybody knows Twitter and Threads, so it's pretty clear that there people use a lot of abbreviations and short names, and also there are things like spelling mistakes and creative spellings, and also people use hashtags, emoticons, and you also see a lot of URLs going on there. And the main problem is the veracity is very much high. So almost 500 million tweets are generated per day. So you can imagine, like, right this moment, there are so many words that are being created which are not there in any vocabulary at all. And there are some other meta information that comes with social media text, like who wrote the post and how many likes were there, and also the date, location, this kind of temporal information are also there. And unlike the other domain, what happens is this is written by the common people. So most of the time, the text that we'll be getting are opinionated. So Stanford Code NLP is like a package for doing sentiment analysis on formal text. So the package that you can download from the website, it's basically trained on a formal corpora. Just to give you an example, like how different it is. So this model is trained on the formal corpora. So you can see, like, informal domain. Sorry for that. So informal domain, the accuracy is near like 86%. But if you like apply it on Twitter directly, then the accuracy drops to like 40 to 50%. So that concludes that this is. Like the model trained on formal domain cannot work very well in case of social media text. So we are going to break this talk into like this outline. So I think once you get out of this talk, I want you to like have a feeling of building an app with like social media data. So I'm firstly briefly going to touch upon on the how to collect data from Twitter. So because all the other social medias are not by default public, only the Twitter tweets are by default public. So you can use, I mean, you can download tweets from Twitter legally, and you can do your analytics on your own. So I'm going to talk about the data collection first. So Twitter provides some public REST APIs to download their data, and I have mentioned all the URLs. So basically, what you have to do is you have to register your app. Like with your Twitter ID, you can register your app at that particular URL, apps.twitter.com. And once you register your app, it gives you a bunch of authentication keys, which are required for your client and their API to talk to each other, right? So moving on, as I said, it provides some REST APIs. So you can install a package called TweetPy, which is like a package, but it's like a wrapper over all the APIs so that you can get the data very easily. So you have to set up your OAuth interface like this. So basically, in a piece of code, you will mention all the consumer keys that you are getting from registering your app at the website. And yeah, you can pass on all the tokens over here for the authentication to work. So next on, I'm going to talk about, there is an API which is called Streaming API, which gives you access to the data that is being generated every moment. So it's called streaming because basically you don't have much control over the random sample that they are giving to you. They think, I think they give around a random sample of 1% of the entire tweets that are being generated. But I think that would be enough for your app, considering the huge number of tweets in total all over the globe. Okay, so here the interesting thing is you use this string API, and you can mention some of the tracks that you are interested in. If you are interested in Python, or if you are interested in say, US politics, you can use the necessary hashtags that you find interesting, and this API would collect all the tweets regarding that. And with this piece of code, I mentioned the URL over here. You can go through it, and there's a GitHub page also for this, so you can download the code easily. And the point is, it will make all the tweets available in JSON format right in your computer, so you can start doing your analytics. So, and I think for some time back, Twitter has banned storing data in your computer or redistributing the data to others. So that's why it's going to be useful if you are trying to do your own analytics on Twitter data. So next thing I'm going to talk about, yeah, go ahead.
Can you specify a keyword for the tweet that you use?
Yeah. So here you can specify.
You are interested in whatever nuclear power. You say.
Yes. So if you're mentioning a hashtag, it will get only the hashtag data, and you can mention individual words also. That's also fine. Any other question on this? Okay, moving ahead. So this is an interesting part because this is social media text, and we are going to deal about all the noisy elements that are there in the social media platforms. So what are these noisy elements? So as for example, there are a lot of slangs in the text. There are a lot of misspellings. I think everyone knows about copy. And there is there are elongated words people use to express their, what do I say, the intensity of their opinion on something. And of course there are hashtags, there are emoticons, people use URLs all the time. There is random casing, and also you will find these days there is image tweets, right? So I'm not going to cover that. I'm only going to focus on the text part. The interesting part is if you take any normal dictionary, then the coverage would be very low. I mean, as for example, in the previous talk, they talked about word-to-vec, right? Word-to-vec or glove embedding. If you go to use the embedding directly, then you find the coverage is very low. It will be around 50 to 70%. So many of the words are not there in word-to-vec and glove. So how to deal with that? So let me talk about pre-processing the hashtags first. So sometimes hashtag words are very good labels of the emotions behind the particular tweet. As for example, hash awesome, hash anger, or something like that. And also like some research works are there who have created a lexicon of the like hashtag words. So based on each of the hashtags, they have created whether this is positive, negative, or what is the emotion going behind it. But there is a big problem. As I said earlier, like new hashtags are being generated every moment right now, and also like tomorrow there is an event, so some new hashtags will be coming up. Like we have one for this particular workshop also, is 2017, right? So one idea is to like breaking long hashtags into like meaningful words. So as for example, this particular hashtag was very popular during Obamacare debate back in 2011-12, I think. So if you look at this hashtag in general, you won't be able to tell anything because this is not there in the dictionary. But if you break it up into kill the bill, then you probably can understand that this is talking about some negative stuff about the bill. Okay, so the standard practice is to like normalize the tweet into like normal text so that the standard algorithms can work, right? So what you need to do is first of all remove patterns like RT, which is for retweet, and also @ username. And if you have any URLs over in your tweet text that you have to remove. You also, since there are like a lot of misspelled words, you have to use some kind of dictionary to like correct the misspellings that are there in your tweets. You can also use tricks like expanding abbreviation using a slang dictionary. I think, yeah, I have mentioned the slang dictionary over here. It contains all the common slangs, common internet slangs that are there, and you can expand them and use to augment your tweet. So you have to remove the emoticons because those are not there in word2vec or anything. And the important part is like handling negation. So presence of not can negate the meaning or the polarity of the target aspect, right? As Wenqiang mentioned. So that's an important thing. We're going to talk about later, like how this can be handled more gracefully, rather than just like taking some hand-coded feature. We'll talk about that later. Any questions so far? So since we are done with the pre-processing, I'm going to talk about some of the models that are commonly used for this particular task. So I'm going to talk about some of the rule-based models. So Wenqiang has already touched upon some of the rule-based models. And also I'm going to talk about some of the conventional machine learning models. And I'll also talk about some of the deep learning models that have that has come up recently. So in case of rule-based models, these are like handwritten rules based on the lexical presence in the piece of text. I'm not going to talk much about the how the rules are formed, but there is a system which was used in the same evil task, which is called Datagram, and it did fairly well. So the thing is, you have to use blogs and forum posts and customer reviews to come up with these rules on your own, and you have to like employ an expert to do this. The main advantage is it gives you an explicit knowledge about what you call as positive, what you call as negative. But the obvious disadvantage is the coverage could be very low. So in that simple task also the recall was very low because it was not covering most of the stuff that was there. And also it has very poor extensibility for like new domain and new data domains. But the good part is like if you are able to figure out some of the rules that are there, then you will be able to use them as statistical features into the conventional machine learning models. So we'll move on to that. So in case of conventional machine learning models, as you know, I mean, Wenqiang has already talked, you need a bunch of features for a classifier to understand whether a particular piece of text is positive or negative. So these are some of the standard features that we have. So as for example, we take n-grams, we also take character n-grams to like because all the words are not there in the dictionary. And also you take the emoticons, but not the emoticons. So you have to use some kind of emoticon dictionary, like you classify whether, I mean, what a smiley looks like or what a, I mean, angry face looks like. You have to classify that. I mean, you have to use a dictionary for that and use that as a classification. And also you can use the hashtags, like if you are using the hashtags in the raw format, then it probably will not work well. You can always use the number of hashtags as a feature, But the good part is like you can always break the hashtags into smaller words and you can use them. Also, there are like you can use the capitalization, you can use the part of speech tagging. But though in my experience, I have seen the part of speech doesn't work very well because the tweet texts are often very unformatted. So the normal pause tagging algorithms that are there, they do not work very well on tweet text. And also, like you can use the negation words, and you can use some tricks like if a negation is occurring before a polarity word, then you can reverse the polarity of that. And also, we have used some tricks like augmenting the tweet with some of the features. So as far some of the features that are mentioned in the tweet itself. As for example, there are many tweets these days which says like, have a look at this http some URL, right? So you never know like what is this tweet talking about. But if you actually follow what the URL is about, then you might have an idea like whether this is talking about something positive or something negative. So one idea is to like download the content of the URL itself and do some sentiment analysis on that and try to try to use them as a feature for your ultimate task. So normal classifiers like linear, SVM and multinomial knife base have worked well in the past for like this kind of task. I think linear SVM was used in almost all of the same-event tasks that were there. Can you excuse me for a second? I think I need some help. It's not the latest slide. It's the old one. Can you download the latest slide?
So is it urgent?
Yeah, so there is some new content in the latest slide.
You just
I think we have here.
Did you find your names? This is your name.
Why don't I see my slides here? Refresh it. Yeah, this is the correct one. Okay, so I think we are using an outdated slide, so sorry for the interruption. So moving ahead, now I'm going to talk about some of the deep learning methods are there. I think the previous talk already introduced you to like the word embeddings. So in case of deep learning, you have to convert all the word to embedding space so that the like hidden layers can work upon. They cannot directly understand the individual words. So what is word embedding? Word embedding is basically a representation of all the lexical items or words into some low-dimensional vector space. So as for example, if you have this bunch of words and you have this like occurrence counts in all the documents, then you can come up with a compressed form of this. So this is a real valued vector and all the words have some value in all the dimensions that are there. So there are different ways of like building this kind of a compressed vector space. The most common ones like the What2Vec and Gallup from Stanford, I think, are trained using deep learning. So the idea is like keep semantically or syntactically close items very close in the vector space also. So if you train an embedding, it might look like this. As for example, you can see like the words like new and old are coming together because they are used to like describe the situation of some particular entity maybe. And also the words like much, little, less, more, these things are coming together in this vector space, which means that this probably quantifies some entity. And also some temporal entities are here, and yeah, here also some temporal blocks are over here. So this is an example of word embedding, and you can use this word embedding as features of your text and pass it to a multi-layer perceptron model, which can do the classification for you. So, but that is like more of a bag of words model, as he talked about. Like basically, you take the embedding of all the individual words and average out, and then pass it to the classifier. But we need to be more careful because the composition matters. Like it's not only the set of words that gives you the meaning of a particular piece of text. So the main point is, if you are using like only bag of words or bag of n-grams, then they do not take into account the composition. So you have to use more principled models, as for example, convolution networks, which takes into account some patterns, and also the LSTM in general, like which can encode the sequential information in the classification process. So I'm going to talk about an example. So this is basically the engine behind Stanford core NLP, and so they call it a sentiment composition. So basically, have a look at this particular string. This says this film doesn't care about cleverness, wit, or any other kind of intelligent humor. So this is the dependency parse tree of the entire string. Now, so normally the English sentences are composed in the way like subject, then verb, then predicate, right? So this film is the subject, this is the verb, and this entire thing is the predicate. And the dependency tree is built in that way. So now what it is trying to do is, the intelligent humor is always a sign of something good. But in the long run, if you parse the entire tree, it is being followed, it is being preceded by doesn't. So the entire meaning at the root should get negated. So that's the idea of this this approach. So this is better in the case, like Wenqiang mentioned, that if there are like negations in your sentence, then how do you handle that negation, right? So if you are using some kind of rules, like if negation is followed by a positive word, then change the polarity, then that might not work in this case, because this not is far away from intelligent humor. But if you have some kind of dependency parse tree like this, then you should be able to understand that in the root, it is actually negating the whole sense of intelligent humor. So to give you an example, like these are the words like not very good, and these are the embedding layers. So now very good is like enhancing the polarity strength of the word good, but since it's preceded by not, in the end it would become a negative value. And you can use standard forward or backward propagation algorithm to learn all the weights of these edges. And these actually outperformed all the bag of words based models and all the state-of-the-art models in 2013. I think it obtained an accuracy about 86%, like I talked about before. So this is a good idea to go about the negation thing. So in the rest of my talk, I'm going to talk about some of the variations of sentiment analysis, and this is becoming a hot, area of research, in the sense like traditional sentiment analysis. I think very less number of people do this anymore. But what is happening is, because of social media, so many platforms are coming out, starting from e-governance, starting from e-commerce, down to like health forums, where people are posting. Also MOOC forums are there, and we are trying to understand like what are the problems that the customers or the students or the patients are facing. Right. So I'm going to talk about some of the emerging research that is coming out to be very interesting. So one variation is opinion mining. I think Wenqiang introduced this task. So what is an opinion? So mathematically, opinion can be defined as a quintuple, and there are like 5 variables in this. So O is like a target object, F is like an aspect of that particular object, SO is like what is the sentiment of the user about that particular aspect of that particular entity, H is the opinion holder, That means that if you have a long document of review, say one particular sentence can be talking, say, can be saying something like this, like the camera of his phone is not good. So this entire sentence becomes the opinion holder, and T is the time when the opinion is expressed. So the task in general is to like extract all the opinions that are there in the entire document. So basically, given the review, you have to mine the 5 corresponding pieces of information of this tuple. If you can do that, then basically, given a review, you can generate a structured format of what was felt good by the customer and what was felt bad by the customer, right? So given, let's move on to an example. So this is also called aspect-based sentiment analysis. So opinion can be of many factors. For example, we have seen in the US election, right? So there are many people who have openly talked many bad things about Trump or Hillary Clinton. Then there is a target person. But in other domains, as for example, product reviews, there are like multiple aspects of a product. As for example, a smartphone can have a good screen but bad battery, or good camera but a bad operating system. So take this example as well. So he's saying that to be completely fair, the only redeeming factor was the food. Everything else was bad. So here he's talking well about the food aspect, but he's talking negatively about everything else. Sorry. So if you do the sentiment analysis on this as a whole, it doesn't make sense. But if you can like figure out what is the aspect and what is the associated sentiment behind it, then you can use it somehow. So there are a couple of models to do aspect-based sentiment analysis. So some of them are supervised models, which use some engrams and character engrams, and also they use some very task-specific features. As for example, sorry about that. So you can have some seed words, like what are the words that are generally used to describe food. As for example, delicious can be a word which is associated with food, but probably delicious is not going to be associated with movie, right? So if you have some kind of training data like that, then you can come up with this very easily, that if someone says the pizza was delicious, then you can probably say the pizza thing is a food and not a movie. And also the waiter was rude. Food cannot be rude, right? Only some service person can be rude. So you can understand that this is talking about service. There are some unsupervised models also who try to tackle the same task, and they try to use topic models, word-based topic models, to figure out like which are the aspects and which are the sentiments around. I mean, what are the sentiment around it, right? So they normally use some seed words to initialize the polarity class, as I told you just some time back. Like the polarity around food could be different from polarity around, say, a camera, right? So you have some seed words, and you build your model based on that. And as the model sees more and more document, it's automatically able to identify what are the like aspect-dependent words, and the models runs in this way. This is very recent work. This was published in 2017 itself. And also there are some deep learning based models, and I'm not going to talk about that here. So this is going to be my last slide. This is talking about sentiment analysis in like health forums, which I'm personally working on under Professor Mian Khan. So this is this concerns about the consumer health forums. So like where people share their clinical experiences with other people in the community. So they try to learn about like other treatments, or like what are the side effects of a particular drug and things like that. So and this is becoming very critical for well-being of patients, not only in, like for chronic diseases, say ALS or multiple sclerosis, and also this is becoming important for like mental health patients. You know, I mean, the most common things about youth today is like the depression and anxiety, and the unfortunate thing is in most of the cases these things go unnoticed. No one notices them. I mean, once diagnosed, it can be helped, but otherwise there could be tragedies happening. So for this reason, like mental health forums are getting popular, it like provides a platform where you can get emotional support from the other users or other patients in the community. And we have tried to do some sentiment analysis in mental health forums. We have there are research works which show that it can detect the early symptoms of depression from social media text or like health forum posts or even from the Facebook posts that you make. And in our work, we try to track a patient's emotional status over time. So like, and we found that as the patient uses the platform more and more and he listens good things about from the other users in the community, the emotional states generally get better. And this can be very useful because if we can do this early, then it can help us prevent like life-threatening situations, which are always very unfortunate. So the standard features for depression detection are in general like the increased negativity in the user posts. So you can always find some depressive clinical terms like suicide or self-injury in their posts, which are very much indicative of the depression. And also there are some social features which points out to the depression that is going on. As for example, people with depression tend to withdraw from all sorts of social interaction. Let it be like offline interaction or it could be online interaction. We also found that like people who are getting benefited from the community, right? They try to reach out to the other people. So the point is like as you help out other people, it can help you in turn also. And we are here, we are going to present this paper in the TMNLP conference in September. So the point is like there was a paper which talks about like how social media will shape the public health in the coming few decades, right? So in countries like Singapore, where everyone has access to like the online platforms, I think this kind of technologies would be enabling the government to like do a better kind of monitoring, and also like it will enable the government to work for the like for the better public health. Okay, to summarize, we talked about how social media text varies from the formal domain. We need to do text normalization and a lot of cleansing to get the data in the right format. We also discussed about ways to collect social media data, as for example, how to collect data from Twitter. We also discussed about what are the standard features for some of the state-of-the-art models. We have discussed about how to use them with like standard machine learning classifiers and also with deep learning models. And we discussed about some of the variations of sentiment analysis like opinion mining and aspect-based sentiment analysis. And we have also talked about some of the recent implications of this kind of task and some of the emerging research directions. So any questions? Hang on. Thanks for listening.
Dan, questions?
Thanks for the insightful talk. Can I check with your team if any sentiment analysis used in education and learning context?
So, yes, so one group of students under ProcMean is working on that. And I think the previous group, right, Muthu was presenting, he works on MOOC data. So he would be able to tell you better about how the sentiment works over there. So he's trying to use those kind of features to like understand which students need more attention from the teachers. Yeah, so if we can do those sort of thing, then we would be able to scale the MOOC like seamlessly. Otherwise, what happens is you just watch a video and you try to make things out on your own, right?
How about in K-12 context?
Sorry?
K-12, kindergarten to grade 12, is not higher education, that's a school context.
Okay, so I don't know, I mean, if there is a lot of online material available for this, but I'm sure like if there are online material, online interactions from the kids available over the internet, then the research would also pick up. But I have seen like teachers using this kind of techniques to like, not this kind of techniques, like NLP techniques to help them in the assessment process. As for example, like given a lot of answer sheets, it's not possible for you to like spend 1 hour after each of the answer sheets. So can machine learning or NLP can help you like in the assessment process? Those kind of research are being done all over the globe.
Can I check this in the US? You have some research group doing sentiment analysis in.
Yes. So as I told you, like Muthu and Animesh they are working on this kind of MOOC data platforms. So I mean, we can catch up with them. Right.
Has there been any effort to use some sentiment analysis with topic modeling?
Yeah. So as I told you, right? So the aspect-based sentiment analysis, it tries to figure out what is the particular aspect that one person is talking about and what is the sentiment associated behind it. So it tries to figure out like, as for example, if you are going through a lot of reviews in Amazon, you would get always confused, right? Because everyone has a different bias over. Someone is very crazy about the camera quality. Someone is very specific about the battery performance, right? So if you place all the reviews side by side, then you would get confused, like what is happening? Is there any consensus at all? So to help you like decide that thing, there are a lot of works going on which tries to figure out like the group the users in different clusters. So like if you are very specific about screen, then you should read these reviews. If you are very specific about the battery, you should read this other set of reviews so that you get an idea like what this kind of, I mean, what each people are thinking about, you know. So you don't have to see a dump of all the reviews at one place. It can be automatically categorized like which part is talking about what aspect. So I think you can look at these references as, for example, and this one, author or aspect topic sentiment model. So this is basically precisely does the same thing that you asked. So it looks at the sentiment at the very aspect level. So you asked about the sarcasm once. So how to detect the sarcasm? Yeah. Yeah. So I would like to add my 2 cents on that. So it's a hard problem detecting sarcasm, and also in Twitter, like many people use sarcastic hashtags, which are very difficult to encode, and that can ruin the accuracy of your system. But hopefully, some researchers are coming up, like they're trying to detect the sarcasm in text, you know. And how do they do it? They do it basically using some kind of word-to-vec embeddings. As for example, if you are saying that this traffic is so awesome, right? This is sarcastic. So the model can figure out this traffic jam thing. It's an extreme negative word, but it is being followed by awesome. So there is something fishy going on here, and they try to build up on this kind of observations. Yeah.
Earlier, I was asking about the keywords for Twitter. I didn't need keywords in the hashtag. Like, you know, you have a tweet and you have some maybe 1 or 2 hashtags, but then maybe you want to look for keywords within the rest of the sentence. Is it possible?
Yeah. I mean, just you don't have to mention the hash in case. Suppose you want all the tweets about Trump, then you just mention Trump over there. So I'd like to mention that other than like Twitter, there are some public datasets available for the UGC domain. So if you are interested in doing like building some app on like e-commerce data, there are a lot of Amazon datasets available, which are huge in size. So those are available for free. I will probably put the link in the slides later. Okay. So I think we'll conclude here. Thanks for joining us, and I'll put up the slides in our website later on, so you can have a look at the references later on. Thanks for joining.